Hi friends! Today we're going to be decomposing shapes to find area by subtracting. You might be saying to yourself, wait a minute, that sounds familiar. That sounds like what we did yesterday. If you've reached this point and you haven't done yesterday's math lesson, make sure that you stop and go back and do it. Well, if you're saying that to yourself, then you're right. This is similar to what we were doing yesterday. So I want you to take a second and look at these two shapes. The one with the fox and the one that looks like an L. I want you to think about what's different between them. Well, in the problems that we did yesterday, the cutout is a complete square or rectangle. And the outside, the larger shape, is also a complete square or rectangle. So it makes sort of like a picture frame. But in the problems that we're going to do today, you'll see that the shapes are more like an L or they're more irregular, where you don't see that complete rectangle or square on the outside or on the inside. Okay, so this is going to help us to find the area of more irregular or abnormal looking rectilinear shapes. You might be saying to yourself, wait a minute, we've seen shapes like this before, Ms. Paglarani. Can't we just break it up into smaller rectangles and find the area of each and add it together? Yeah, you could. This is just another way so that you have multiple options in your toolbox for how to find the area of a shaded section in a problem like this. So you very well could split it up into two rectangles, like that, right, to find the area of each and add it together. Or you can use the strategy that I'm going to teach you next. So in this first practice problem, it says, find the area of the shaded space. Okay. So I remember that in yesterday's problem, I started by finding the area of the outside rectangle. So the outside rectangle here, well, doesn't look very clear to me, but what if I went like this? What if I treated this as the outside rectangle? Could I find the area of that space? Yeah, I think I could, because I know the length is 6 going up and down over here, and I know the width is also 6 going across here. So I could do 6 times 6, and that would give me the area of the purple section. What's 6 times 6? 6, 12, 18, 24, 30, 36. And I could get 36 for the area of the purple section. Okay. Now, the only part that's not shaded here, the only part that's not shaded within my purple square is this white section right here. Everything else in my purple square is shaded. So I want to know that. But I don't want to know what's in the green. I don't want to include that in my answer. So I need to find the area of the green and subtract it out. Okay? So can I find the area of the green? Well, I do know the length, 2 centimeters. And I do know the width going across is 4 centimeters. So 2 times 4 equals, for the green I would get 8 centimeters. Actually, I got a little trick there. Should be square centimeters. And I'll label for this as well. Whoops. Okay. I'm not done yet. I'm almost there. So now I found the area of the whole purple square. And then I found the area of the green square. And now I want to take that out so that I have just the area of the gray section. So to do that, I'm going to take 36 and I'm going to subtract 8. And if I count backwards, well, I know 36 minus 6 would be 30. And then minus another 2 more to make a full 8 that I subtracted would be 28. And it would still be square centimeters because I'm talking about the area of the gray section. Let's try another one. Oh no! Alex's little brother cut a piece out of his math homework that's shown below. How many square centimeters of his math homework does Alex still have? Okay, so as I read that, I know that the part that's cut out is the part that is missing from the homework. So the rest of the homework is the gray section, right? So I'm going to note that to myself, right? I'm trying to find the gray. Oops. There we go. Trying to find the gray section. So I'm going to use that same subtraction cutout strategy that I just used. So what I'm going to do again is make a big rectangle around the outside. I want to make sure it's as clean as I can get it. There we go. And then I'm going to outline the missing section that's not gray on the inside. Okay. Now I'm going to find the area of the whole red area. So again, length 10 times the width 8. Notice how again that length always goes up and down and the width goes side to side. 10 times 8 is 80 square centimeters in this problem. Then I'm going to find the area of that missing section, right? So what I highlighted in orange. So again, I start with the whole figure, and then I find the area of the missing section. So again, I'm going to do length times width, so 4 times 5, and 4 times 5 is 4, 8, 12, 16, 20. 20 square centimeters, and almost there, but not done yet. Now, to find just the gray part, I'm going to take the area of the red section, which is the whole thing, includes everything. Maybe I'll even write that out here. All right, the whole shape minus 20, which is the area of the cut out. And then that would give me, what's 80 minus 20? I can do that super easily in my brain. 80 minus 10 is 70, and 70 minus 10 is 60. 60 square centimeters. And that is the area of the gray section. All right, friends. Now that we've done some practice problems together, it is time for you to go back to Google Classroom for your exit ticket. I hope you have a wonderful rest of your day.